Hello guys, my name is Pavel Čermák and I'm a CEO of Hype Digitally, AI automation, integration agency, software development company from Czech Republic. I founded it in 2022, so we already have over almost 3 years of experience building production-ready AI chatbots, voicebots and agents. And today I want to talk to you primarily about RAG, Retrieval Augmented Generation. Why is this the basically main framework we use to deliver these agents? What is it, how to approach it, and what are the best practices and from the experiences we have gained over 3 years of experience. As I said, we have basically deployed many chatbots and agents in production with over almost 95% RAG accuracy in live deployments, mostly in enterprise niche and governmental niche. So far, Czech Republic consists of 13 regions and we have managed to deploy AI assistants in 5 of them actually up to this date. And overall, we have delivered over 30 projects built on multiple platforms like primarily VoiceFlow, N8N, Make.com and all these no-code bot building platforms. So what is RAG? RAG stands for Retrieval Augmented Generation and it's primarily for the use case when you want to ask the AI about information it has not been natively trained on. LLMs natively have knowledge cutoff late 2024 or early 2025, nowadays the latest models, and the AI doesn't know your data unless you give it access. So when you want to train the AI or LLM on your company documents, on your website information, you need to use RAG for this specific use case. So why it matters? If you want the AI to have current and up-to-date information about your company documents, your URLs and everything. If you don't want the AI to hallucinate, just make up facts or make up nonsensical information or just extrapolate information that's not inside the documents you gave it. And there is also important limitation to LLMs, and that is context window. That means basically how much information you can put inside the LLM, and you are limited by that amount. So you need to be able to properly structure and divide your information, load it and place it inside so-called knowledge base or vector store. So a RAG system basically consists of 3 different components, and that is your knowledge base, the search and retrieval mechanism, and the LLM generation. So as you see in this diagram, you have the knowledge base, where is all your company information, URLs, and basically any information you want the LLM to have access and answer only on this reference information. Then there is the search and retrieval part, when you input and send a query inside the vector database, you only want to retrieve up to n basically most relevant pieces of information or context, and then you want to take this returned information alongside with your query to the LLM, which needs to be properly prompted by latest prompt engineering practices, specifically focused on RAG in order to produce the most optimal and precise response you want to give the user that's basically grounded in the provided sources and nothing else. So you could say the entire RAG pipeline or process is divided into 2 sub-pipelines. That would be ingestion pipeline, when you load the information from the provided sources you gave it, like the URLs, documents, PDFs and everything, into the knowledge base. Then you chunk the information in order to adhere to the context limitations and chunk limitations of the vector stores. You structure it properly and you store it into the DB or knowledge base. Then there is the retrieval pipeline, when you want to have the optimal query to send into the knowledge base and retrieve the most relevant pieces of information to the query and basically generate the most precise response as possible that's grounded only on the provided documents you store in the knowledge base. So now let's look what are the main problems with RAG and GenAI projects and why 95% of these projects fail in production. As you can see, when you search this in Google, there are tons and tons of articles and documents and case studies around this, and it's actually from the latest McKinsey or MIT reports that this number, 95% of GenAI projects actually fail and don't deliver on the promises to the clients. So problem one is actually the data structure. How to upload the company data, dozens of thousands of unstructured URLs and documents into the knowledge base in structured formats. How do you do this exactly? That's the biggest problem of most AI agencies, software development companies, or beginners who delve into the AI space and don't know how to build these. You'll see tons of tutorials in YouTube from these YouTube gurus. They show you how to build simple demos, connect like simple flows together, but they don't show you basically how to take these entire huge websites or tons of thousands of documents into the knowledge base and query it and for the bot to answer with utmost precision and not to hallucinate, extrapolate facts, or claim confident nonsense. Problem 2 is chunking of the information. In ideal world, each single and whole document or URL's content would whole sit each in its own chunk with clean and well-structured information. Unfortunately, that's not how it works, and vector stores and knowledge bases have token limits. So maximum allowed chunk size varies from 500 tokens up to 4,000 tokens for most vector stores. So most platforms use these naive chunking strategies, how they say it, and they divide the content by fixed token counts. So they allow between 800 up to 1500 tokens for a single chunk. So the biggest concern is how you divide the entire document or the entire URL's content into the chunks so that it makes sense and they are not cut off in the middle of the sentence, right? So let's look how it works in practice, for example, with this article. If we were to take the entire URL's content from this article and upload it into a knowledge base, we would need to split its entire text in multiple chunks. And if I were to convert and extract the pure text from this HTML site, which I just did, and I calculated the number of tokens from the entire site, it was 11,000 tokens. So at maximum, with some particular vector store that allowed 4,000 tokens, we would be allowed to split it in basically 3 parts with 4,000, 4,000 and 3,000 tokens, right? But the biggest problem, if we were to approximate exactly where the content would be chunked, for example, it would be in this particular case somewhere in the third of the site. It could be cut in the middle of a sentence, for example, somewhere around here, and that the entire contents from that part up to the beginning of the page would be the very first chunk, right? But as you can see, the problem is how you basically make the continuation onto the next chunk. The next chunk would start in here and would continue up to next 4,000 tokens somewhere in the second third of the website, which could, by the way, end somewhere around here, for example. And again, you would have the same problem. The third chunk would begin somewhere from the middle of the sentence and onwards up to the end of the document. So when you take a look at this example third chunk for this example article in this website, let's say we would have a fixed token count, what most platforms do, as a token overlap before this chunk. So before this chunk, we will just take somewhere around here, these highlights up to this word they agree, and all of these words would be this token overlap before this third chunk, and that would be the only thing that basically gives the LLM some kind of context, basically where the second chunk ended and where the third chunk basically continues. So, as you can see, we have two big problems with traditional rec systems and what most platforms actually do. First is chunking. How do you optimally chunk the URL's content or PDF so that pieces of information that logically fits together actually belong together and sit in their own chunks? So that's the first problem. How do you chunk the text in most optimal way? The second problem is the LLM has context about how the current chunk basically plugs in and fits into the context of the overall PDF, document or URL. So each chunk should basically have a reference and summary about the entire document, entire page or entire PDF, and summary also about the current chunk, summary about the previous chunk and how the previous chunk ended and how it continues and plugs together with the next chunk. So that's exactly what I write about in here, that each coherent section of the URL or document that belong together logically would sit in their own chunks, plus they would have metadata for the LM, as I said, to have big picture idea, because it would have metadata fields like page number, URL link, summary, how the chunk before ended, current chunk summary, source page summary, and so on. So that goes into the next problem. As we are talking about it, each chunk should have rich and detailed metadata. For example, like origin, document file name, page number, URL link, fields for filtering so that you can narrow the search during the search and retrieval pipeline in the flow, and basically you can retrieve as much relevant information as possible. And as we already told, current chunk summary, chunk overlap summary for the resulting LLM generation to have as much context, and it could basically take chunks from different parts of the website and basically plug them together so that it knows where the particular chunk ended, where it continues, and it can get logically coherent sequence of the chunk and basically reconstruct the entire document, which basically gives much more precision in generating the desired response. Last but not least is automated updates. You need to be able to update your knowledge base or vector store in regular intervals, be that hours, days, weeks, months, in order for the LM to have as relevant, current, and up-to-date information as possible for it not to hallucinate or either give outdated answers to you or your client. So in terms of automated updates, you basically have two problems. One is how you basically make the knowledge base update only those sources, URLs, documents, which changed since the last run. So you do this basically by connecting the XML sitemap and reading the last modified values of the URLs or documents. You need that in order to assess if something changed on that particular source since the last knowledge base update. I guess you've already had that issue when you needed to rescrape the entire client's website or re-uploaded that PDF because the bot or agent you built didn't have up-to-date and current information. And the second thing is that you need to deduplicate properly the information so that the agent, if the more and more scraping and executing of updating the knowledge base, doesn't get bloated and saturated, and so that for the accuracy of the LLM doesn't get saturated as well over time. So in the very next video, I will show you the difference between a good chunk, a bad chunk, what constitutes and makes a good chunk of information for the vector store and LLM to retrieve the information correctly with utmost precision and generate the best answer as possible.